Okay, so let's talk about the bell ringer. Again, some of you might not remember. It's okay. When you are factoring, the goal is for you to put it in simplest terms. You have to look at both of them and say, what is common between both? Okay, so for the GCF, 2. So that means I can take a factor of 2 out of both of these. So what is 2 divided by 2? 1. So then I have x squared on the outside. And then we bring down the plus sign. What's 18 divided by 2? Not 6. 9. Thank you.
I knew that.
Mine look like Z's kind of, so I apologize.
Is it an x2 in the parentheses? I see it like Z.
Yeah, x squared. I'm not used to writing this early in the morning, so bear with me. Okay, so again, when you're trying to factor, you're trying to find something that's common, and 2 was common in the very first one, and we divided both of them by 2, and that is now our answer. Now, difference of 2 squares. I feel like a lot of people like difference of 2 squares. All you have to do is take the square root of both terms. What's the square root of x squared? 1x, yes. So what I do is I write my magic number. I call them magic numbers on the top. What's the square root of 121? 11. Does anyone remember how I would write this out from when we did?
Oh, yes. 1x
Yeah,
plus
x.
11, 1x minus 11.
Yeah, x plus 11 and x minus 11. And we're done. See, you remember. That's awesome. Do you have any questions at this point on just the bell ringer? Yeah. Okay. So you were given a purple packet. The purple packet is like half of the notes. Usually I have them all ready to go, but this is a new, we're introducing the unit back this semester because for a lot of you that are going into Math 098, which I feel like 90% of you are, Math 098 next year, because it helps you go to JJC. If you're planning on doing that, you have to know the stuff we're about to learn in this next chapter. That's why we brought it back. We took it out last year, and we brought it back this year. So you only have half the notes. We'll give you the rest of the half next week. Okay? So kind of just a little cover sheet here. If you get stuck on factoring, here's how to do that. So if you look at the first problem, there were only 2 terms. Okay? So I could do, always factor out the GCF. The second one had 2 terms, and I did difference of 2 squares. So it kind of just helps you if you get stuck when it comes to factoring. The back page of the purple sheet, I put a multiplication chart on there for you in case you need that, especially when we get to adding and subtracting fractions next week, which I feel like some of you might need that when we find our least common denominator. Anyways, this is only 1 page front and back, so let's go ahead and get started on that. Simplifying rational expressions. So last chapter in chapter 9, we did rational expressions. Rational expressions are just something that has a ratio. Like 1/2 is a ratio. Okay, that's what a rational expression is. A rational expression does not have an equal sign, whereas a function does have an equal sign. If you look at all the problems that are below, they do not have equal signs because they're expressions and not equations or functions. Okay? So to simplify a rational function, we're going to factor the numerator and denominator and cancel things out. Or people just call that reducing. I know that people like to reduce when simplifying fractions. So let's look at this very first one. What number goes into both 18 and 12? 6. Very good. So kind of just to help you out here, what would I have to divide? Oh, sorry, you just told me. I divide both of them by 6. Is not 2. 3. Good. So 3/2, and that's my final answer. Okay, we're just taking it slow at first. Pretty straightforward. We just reduced. Some people like to just cross out and put 3 and 2. It really just all depends on who you are. Let's look at this next one. Take each piece at a time. How do I reduce 25 and 30? What number goes into both of them? 5. Okay, so I have what on top?
5.
And what on the bottom? 6. Very good. Because 25, I'll even write that out, divided by 5, so you don't forget or you want to see where it came from. 5 over 6. Now let's talk about x squared divided by x. Okay, hopefully you kind of remember from when we've done this in the past or from last year. What'd you say? They kind of cancel out. Does anyone know what happens? You do. Thank you. You actually subtract exponents. What secretly is right here?
1.
A 1. So what's 2 minus 1? 1. Now let me ask you, is the x going to be on the top or the bottom? The top. Very good. Because the bigger number is on top. And we're done. Or you can think of it as I have 2 x's on top, 1, 2, and I have 1 on bottom. Well, 1 cancels out. I'm left with 1 left. All right, so this next one. Okay, we're just taking it like one step at a time. Six and 3. Well, this is actually pretty easy because what is 6 divided by 3? 2. So I always just like write my fraction ready to go.
Could you use 3?
Well, you could, when you divide by 3, you get 2. So like if I divide by 3, yes, I know what you mean by that, yes. When I divide by 3, I do get 2. Now, kind of what we did last time, but now notice the bigger number is on the bottom. So where is the x going to go? On the bottom, good. And how do I know that? Because 2 minus 1 is 1, but the bigger number is on the bottom.
So would that one get x, y, and not get z?
Where would the y go? On the bottom. Where would the z go? And how many z's do I have? 2. Oh my gosh, see? This is easy review for you guys then. Here's how we knew that. 3 minus 1 is 2. What'd you say?
I don't even know we learned this.
Oh, this is like maybe freshman year.
Oh, what?
Yeah.
No wonder. How is that freshman year? I used to be so good at math.
Well, just here, to kind of just sum up so that you're not confused, when you're talking about dividing, I'm dividing here, right? Because that's what that symbol means. You subtract exponents. So 4 minus 2. But let me show you why that works just for the sake of understanding why. So let me just do maybe this first one right here. So for those that were stuck, you're kind of like, why? How did that happen? I'll show you why. Are you guys okay with the numbers? Yeah. Okay, so let's talk about the letters. Really what the top means is x times y times 3 z's, right? Because z cubed means I have z times z times z. On the bottom, it would look like this. So for those that got stuck on this, I would write this all out just so that you understand. This means I have 2 x's. This means I have 2 y's. And I have 1 z. Now look what happens. Gone, gone, gone. Well, look. I have 2 z's left. And I have 1 x and I have 1 y. And then you guys told me that we had a 2 on the top. Do you kind of see now why? Okay, good. So doing the subtraction trick is actually, I think, faster and better and more beneficial for you in the future. If you had to write all those out, it would take a long time when you get to some harder problems, right? I know Kobe's ready to go. He's looking for the answer to make sure I'm getting it right. Right, Kobe?
Yep.
So sad that I know your name? Just kidding. I just knew you from when you had Bettino.
Oh, really?
Yeah. Because you would like wait in the hallway when I was teaching and I'd be like, why are you here? Just kidding. All right, just messing with you. Okay, so now these ones I put here so that you can try them. They look exactly like the ones right above it. He's double checking your answers on his phone. That's what he's doing.
4x2 over
You should put it away.
3.
Why?
Because I asked, thank you.
In your way, so you're on all 4x over 3.
I'm going to go over, yeah, I'm going to go 4x what over 3? Yes. When you're done and only when you're done, take a look up to check your answers. Oh my gosh, yeah, thank you. See? All I saw was 2. You are correct. I'm going to divide by
I divided by 8.
by 8. Thank you. You are correct. You know what I saw? I only saw the 2 in my head.
Oh yeah.
My brain was like not working right there. Okay? So check, thank you for correcting me. I love when people correct me. So technically that's a 1 and technically that's a 3. You don't need the 1 here, only if you want it.
I hate getting corrected.
Well, that's how math works, okay? You know, I make a mistake, you find it, and then we go from there.
Sorry, as I have it.
Maybe you will do better in math when you don't have it out. Okay, so I'm not being mean at all. I just want you to learn math, that's all. And then once we're done, you can go on all you want. I don't care. All right, so do you have questions on any of those that we just did that you want me to go over? Okay, cool. So honestly, to be honest with you here, that's stuff that you've already done. Now you're going to apply it and do new things with it, okay? Factoring. If you don't know how to do it, make sure you're seeking out help because you're going to have to know how to factor for this unit and for Math 098. Math 098, it's expected you know how to do it like that. Okay, so please make sure that if you're taking Math 098 especially, that you know how to factor or at least pay attention when Ms. Hurd does it because factoring is crucial. Okay, now let's talk about this. When we look at here, technically we'd be like, oh, this cancels, we have 3, right? You're correct. But does it equal 3 for all x values? Is there anything x cannot be here from when we were doing this in chapter 9? What can't we have in the bottom of a fraction? What number?
No, a variable.
Someone said it, 0. We can't have the number 0 in the denominator. Yes, good job. Like if you go in your calculator right now and typed in 3 divided by 0, you would get an error because it's undefined, it doesn't exist. Okay, so we cannot have, x cannot be 0. And that's what we call an excluded value. And we did this in chapter 9, which is the last chapter we did last semester, where we asked ourselves what makes the bottom equal to 0. I think you've heard Ms. Hurd say that a million times probably. What makes the bottom equal to 0? Okay, so now let's just do some examples here. All we're going to do in this part is figure out what the excluded values are. So this one's pretty straightforward. We kind of already did it. 0. X cannot be 0. Oh, did I forget something? There's a blank, isn't there? Right here. Okay, again, because if you put 3 divided by 0 in your calculator, it would not exist. It would say error. Now let's talk about this next one. What makes x plus 3 equal to 0? You're asking that question. Negative 3, because I'd have to subtract 3 to both sides. So x cannot be negative 3. Some of you might have been able to look at that and been like, negative 3, because 3 minus 3 is 0. Okay, if that's you, great. You don't have to show your work for that part, at least for me. But if you didn't know that, set it up to equal to 0 and solve. Now this one has 2. We have to talk about both of them. The amount of x's you have on the bottom is how many zeros you must have. What'd you say? Yeah, here x cannot be negative 1, and here x cannot be 2. Because when you plug them in, 2 minus 2 is 0.
We used to determine whether one is a vertical asymptote.
We did, yes. So for example here, technically that means we have, from chapter 9, we have 2 asymptotes at those numbers. Okay, remember that. What'd you say? I can, yes.
Whether it cancels out as a whole or a vertical asymptote.
Yep, canceling means a whole, and not canceling is a vertical asymptote. Yes, you are correct. When you're done, flip your page so I know you're ready, and we only have one more page left. And the rest of the time is yours for your homework.
I like to save it for home.
That's your choice, because I'm leaving after this. I'm going back to my class. I have a class right now. All right. So,
You want to spend time with us, I know.
I know, I just was really excited about it. Just kidding. I am. I want to make sure that you guys are learning and not falling behind. Miss Hurd was all worried about you. I'm not even joking. She was super like, I don't want to call off. I don't want to miss another day. And I was like, Phil, survive. I'll teach first hour, record it, and have your 5th hour listen to it. Okay? Because she's got a sick baby. You can't do anything about that.
No, it's months.
What's up?
She's missed more days than me. I missed 13 days.
Well, hopefully the baby. She would be here if the babies weren't sick, and you know that. Okay. It is going around, and they're kids.
We have math
Yeah.
to do, people.
I agree. Let's not get distracted because we want to make sure we have time for our homework. So now let's talk about this. Simplify each rational expression and state the excluded values. Well, excluded values are what we just did. What makes the bottom equal to 0. Okay, simplifying. Kind of why I gave you this bell ringer. We want to factor the numerator and denominator first and then cancel things that are the same. So, let's look at one by one. Can I factor anything out of the top? Yes or no? No, so I'm just going to rewrite it. X plus 6. Can I factor anything out of the bottom? What number? 3. Very good. So now when you put that 3 on the outside, you basically are dividing each one by 3. So x plus 6. Very good. Okay, so now we're here. Before I do anything, let's find our excluded values, because that was step 1. Step 2 is to find your excluded values, which makes the bottom equal to 0, which someone told me was -6.
What do you do with the 3?
The 3, there's no x attached to it, so we're okay. You're only looking at the things that are with the x, so good question. The very last step, cancel like factors. What cancels?
X plus
Yeah, the whole group. And now I'm left, when you cancel something, it becomes 1. Whenever you cancel it. Why? Because 3 divided by 3 is 1. So that's how we would write that out. So the final answer is 1/3. Now I set this up so then I do 1, you do 1. So try number 2 because it's very similar. Try to make sure that I did that to make sure that you had practice with it. Okay, so it's very similar to number 1. Just give it a try and see how you do. If you need help by a partner, ask them or ask me. If you can teach someone how to do it, then you're golden, you're set. And follow the steps. So I even wrote them out in the last one. I put step 1, step 2, and step 3. Step 1, step 2, step 3. All right? Try to follow that. I'm coming your way. Yep. All right. Take a look at mine. Okay, so people were getting stuck on the factoring part, and that's very common again because I feel like factoring's tough for some people. You ask yourself, what number goes into both them? 4. So I divide each one by 4. So for those that were stuck on the factoring, it might be beneficial to write on the side that you divided both of them by 4. Whatever you write on the outside is what you divide both of them by. Okay? Well, then when you factor it, these will cancel, and you're just left with 4. 4 is the only thing left. Okay? Might have to take a factoring day tomorrow instead. Make sure that we're ready for this. This is like the easier ones. Okay. Okay, now let's look at this next one. Now, again, step by step. Step 1 is to factor both the numerator and the denominator. Now, I always start with numbers first. Good, I can factor out a 3 because 3 goes into 3 and 6 evenly. I could put that in a calculator and I would get a nice, pretty answer. So 3 is on the outside. Is there something else I can factor out besides 3 that's common? Now let's look at letters. X. Now, you want to factor out the smallest exponent. Why? I can't take 2 x's out of 1. There's only one of them. Okay, so I can only factor 1. There's only one common. So now, we're going to divide the 3x squared by 3x. What are you left with? Good, 1x. Now when I divide this guy by 3x, what do I get? 2. Because 6, the x's would cancel, and 6 divided by 3 is 2. Do the bottom now, because again, you have to factor the top, then factor the bottom. What number first goes into both 6 and 18?
3.
3 is correct, but you can go higher than 3. So 3 is not wrong. 6. Okay, again, that was awesome that you mean 3 is fine. It just, there's a higher number. Now look at your exponents here. I have x cubed and x squared. So how many can I take from both of them? Only 2 of them. Again, I can only take 2 because this one doesn't have 3 to give. So now I'm dividing this by 6x squared and dividing this by 6x squared.
So it would be 3 to
1 what?
X plus.
You're right.
x plus
And 2 divided by 6 is
3.
2 would cancel out.
It is 3, yes. Okay? Here's why, because this is gone. And remember we said that we subtract exponents, 3 minus 2. Okay, so now we have to talk about our excluded values. We have to talk about both of them. Every x we have to talk about. If you ever need highlighters, I do have a bunch of them. They're in there. What makes this piece equal to 0? What number would I have to plug in right here to make it 0? Well, 6 times 6 is 36. We're good there. What would I have to plug in to make anything 0? 0. Okay? X can't be 0. Why? Because 6 times 0 is 0. Undefined. Can't happen. Now what makes this one, so I'm going to draw like an arrow so you know that's where it came from. Good. X can't be negative 3. For some reason, a lot of people forget the first one because it's like straightforward, and that's totally common.
Can I use 2 for both parts?
Yes, if there's 2. X cannot. Well, no, you don't have to do the top. Well, you can't. You don't have to do the top. That doesn't make sense. Because the bottom's the only thing that can be undefined. I can have any number in the world on the top. Doesn't matter. Now, really, there's no big groups to cancel, but we can cancel some small things. This is the very last step. This is step 3. What number can go into both 3 and 6? 3. So I'm left with what? What's 3 divided by 3? Well, we're going to get there. What's 3 divided by 3? 1. What's 6 divided by 3? 2. Okay, so that reduced. Some people just like to do this. I know people have done this in the past. Some like to cross out and know, okay, this is going to become a 1, and this is going to become a 2. Let's put 2 there. Okay, some people do that. That's okay. Now let's talk about these x terms. X divided by x. I have 1 on top and 2 on bottom. How many cancel? 1. And where is the remainder? Is it on the top of the bottom? Good. Awesome. These don't cancel, so just write them. Okay? If they don't cancel, you have to just rewrite them. And you're done. Okay? Going back to factoring, which is in chapter 6. Okay, and if you need to rewatch the video, do so to make sure you're getting it. Okay, sometimes maybe watching it a second time is all you need. Okay, all right, I want you to try 4. This one's actually easier than the last one we just did, but it's similar. This one's easier than the last one we did. Step 1 is to factor. Ask yourself, what numbers can I pull out and what letters can I pull out? I know that. Yeah. Is it? Yeah. For you. And it's a great way to see how you're going to do when you go to JC. All right, let's move on. But anyways, you ask yourself, what number goes into both? It was 20. I'm just going to skip some steps here. 20 went into both of them. Now look, you don't have to write divide by 20 every time. You can just go 40 divided by 20 is 20. And then 20 divided by 20 is 1.
Wait, shouldn't that be just a
2, yes. I keep doing that, man. All right, 2. All right, the bottom. 10 is the thing that goes into both of them. So I'm going to write it on the outside. 10 divided by 10 is 1. 30 divided by 10 is 3. Now the only thing here, the excluded value is -3. Just going to write that outside here just so we know. We're just running out of time, so I want to make sure we get through it. How this reduces. 10 goes into both of them. So I am left with 2 on top and 1 on bottom. Because 20 divided by 10 is 2. So our final answer is 2x plus 1 all over x plus 3. It's okay if things don't cancel. We're only going to do 5 and that's it. Because then we can save the other harder factoring for tomorrow. So I feel like that's something that we need to go over factoring tomorrow. All right. So let's look at this first one. I gave you a bell ringer just like this for a reason. I can, yes, absolutely. Can you see that? Okay. What's the square root of x squared? 1x, very good. What's the square root of 49?
7.
Very good. How would I then factor that? I have x.
Plus 7, x 9.
Good. Oh, no, that's x. Okay, now look at the bottom. Remember, we factored the top and we factored the bottom.
3.
What number? Good. 3 goes into both of them. So I write it on the outside. Well, 3 divided by 3 is 1, and I'm left with x.
Plus 7.
Good, because 21 divided by 3 is 7. That was our first step. Our second step is to tell me the excluded values. What makes the bottom equal to 0?
7.
Awesome. Final step is to cancel things. So this is step 3. What's the only thing that cancels?
X plus 7.
Beautiful. So I have x minus